What is the difference between for loop and while loop in Python? First, understand that both the for loop and the while loop are used to iterate through a set of elements and perform a specific task. Now, the main difference between a for loop and a while loop is that a for loop is used when the number of iterations is known in advance, while a while loop is used when the number of iterations is unknown or when you need to iterate until a specific condition is met. But, what is a loop and how to use each of them? A loop, in computer programming, is a sequence of instructions that are executed repeatedly until a certain condition is met. It is a fundamental control flow structure that allows a program to repeat a given block of code several times. Loops are useful in programming because they allow programmers to perform the same operations on different sets of data without having to write redundant code. They can also help make code more efficient by automating repetitive tasks. There are two main types of loops. While loops. The while loop is a flow control structure in programming that allows a block of code to be executed repeatedly as long as a certain condition is met, hence its name. The code will be executed as long as a given condition is met. When it is no longer met, the loop will be exited and normal execution will continue. In this simple example, we initialize a variable I that will have the counter function with the value 1. Then, we set the condition of the while loop to repeat as long as I is less than or equal to 5. Within the loop block, we print the current value of I to the console and then increment the value of I by 1 on each iteration. This ensures that the loop condition eventually evaluates to false after the numbers 1 through 5 have been printed. This is a very clear example of what the correct syntax of the while loop looks like, so it helps us to understand that it has two parts. The condition that has to be met for the code to be executed. The block of code that will be executed as long as the condition is met. It is important to be careful with infinite loops, which are those that never stop. It is true that in some cases we may be interested in having an infinite loop, but unless we are sure of what we are doing, we must be careful. Let's imagine that we forget to update the variable I inside the loop will never finish and will become an infinite loop. Using the while loop in a single line. In Python, it is possible to have a while loop on a single line if the block of code we want to execute is short. For example, if we want to print the numbers 1 through 5 on a single line, we can do the following. In this example, the while loop and the update of the variable I are written on a single line, separated by semicolons. Nested loops. We have already seen that while loops have a condition to evaluate and a block of code to execute. Now we can complicate things a bit more and put another while loop inside the first one. This is a very useful technique in programming when we need to perform a more complex task that involves iterating through multiple data sets. For example, if we want to generate permutations of numbers, that is to say, to make different possible combinations between the numbers 1 and 3. In this example, we are using 3 nested while loops to generate all possible permutations of the numbers 1 to 3. The first loop iterates over the number I, the second loop iterates over the number j, and the third loop iterates over the number k. At each iteration, it checks if the numbers I, j, and k are different from each other. If they are different, the permutation is printed after each iteration of the innermost loop, i.e., each time it prints whether all requirements are met. The value of k is incremented by 1. When the innermost loop is completed, the intermediate loop is restarted and the value of j is incremented by 1. This process is repeated until the second loop is completed. When the second loop is completed, the outer loop is restarted and the value of I is incremented by 1. This process is repeated until the outer loop is completed and all possible permutations have been generated. Result. It is important to note that the use of nested loops can be complicated and can lead to errors if not used correctly. Therefore, it is important to be careful when using nested loops and make sure you fully understand how they work before using them in your own code. Flowcharts are important for understanding the step-by-step and, with a little practice, nested loops can be a powerful and useful tool in programming. Loop 4. Next we will explain the particularities that it has in Python, because compared to other programming languages, it has some differences. Okay, the for loop is another way of repeating a series of instructions. Unlike the while loop, in which the number of times it is executed depends on a condition, in the for loop you specify in advance how many times it will be repeated. To specify how many times the for loop should be executed, a variable called an iterable is used. An iterable can be a list, a tuple, a range, and so on. For each element in the iterable, the for loop executes the instructions inside the loop. It's as if you have a list of things you want to do, and the for loop helps you do each of those things one by one, until you have finished the entire list. In the following example we see a for loop that is executed 5 times, and where I increases its value automatically by 1 in each iteration. If you saw the information about the while loop before, you probably already noticed the advantages of using the for loop. For example, if we want to create a sequence of numbers that increment from 0 to n, using the for loop saves us a few lines of code, since we don't need to write the code to increment the number. In Python, practically everything can be iterated, such as a text string. In the following example, we will see how the variable I takes the values of each letter in a string. Later, we will explain what iterables and iterators are. To understand for loops in Python, it is important to understand the concepts of iterables and iterators. Iterables are objects that can be iterated or accessed by an index, such as lists, tuples, strings, or dictionaries. Iterators, on the other hand, are objects that allow us to access each element of an iterable sequentially, by using the next method. Both are somewhat abstract concepts that can be complicated to understand. Let's see some examples. In this example, the list is an iterable, and the variable number in the for loop takes the value of each element of the list, one at a time. Example of a non-iterable object. The result if we try to iterate over an object that is not iterable, which generates a type error. Example of iterator. In this example, we create an iterator from the list with the iter function, and then call the next function 3 times to print the first 3 elements of the list. We can continue like this until we try to call next, a 6th time. Here we will get a stop iteration error, since we have reached the end of the list. There are other iterators for different classes. An example with string iterators. Nested for loops are very useful in Python. The idea behind nested for loops is to iterate through a data structure that contains another data structure. In other words, they allow us to traverse elements that are inside other elements. For example, let's imagine we have an array, which is basically a list of lists. If we run this code as is, we would have something like this, but if we want to print all the elements of the array and change it from horizontal to vertical position, we need to use 2 nested for loops. In this example, the variable row represents each one of the lists of the matrix, and the variable element represents each one of the elements of those lists. Range in Python. Use of range. If you already program, I'm sure you're tired of writing this, even if it's in another language. Let's say we want to iterate a variable I from 0 to 5. Making use of what we have seen previously, we could do the following. But what happens? We are wasting a lot of time doing that. Luckily in Python there is a solution for that, and it is called range. Basically, range generates an iterable object that produces a sequence of integers. In this case, the range function generates a sequence of integers from 0 to the number 6, excluding 6. The variable I in the for loop iterates through the sequence and, at each iteration, prints the corresponding value. But in reality the range function is smarter than we think because you can pass up to 3 comma-separated parameters, where the first is the start of the sequence, the second the end, and the third the desired jump between numbers. For example, if we want to print the numbers 1 to 10 in steps of 2, we can do the following. It is also possible to generate inverse sequences, starting with a larger number and ending with a smaller one, but for this the jump must be negative. Finally, it is important to note that using the range function in Python is an efficient and simple way to generate a sequence of integers. Instead of creating a list of numbers one by one, which could occupy a large amount of memory in case the list is very large, range does this automatically, that is, it generates each number only when it is needed, saving memory and processing time. For this reason it is an efficient way to do a for loop and we should all learn to use it.